everything in this video is theoretically correct. Some are not very accurate. I'll point it out.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries, without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net.
Anyone recognize the interface? I first saw this video when I was in my PhD program,
To begin your journey
15 years ago.
the net.
But still, we are using the same internet.
Know exactly what happened when you clicked on that link. You started a flow of information.
Binary.
This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information.
So those are the information, and this is the
Now the package needs a label
data field,
containing important information,
and that's a header.
such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network.
Very important thing. Wrong. The packets are now launched into your network. They are encapsulated one more time. So imagine there's another container bigger than this, and the whole thing goes into the container, and there will be a new header that represents the frame. Okay? So frame hits the road.
Or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN's a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router, a symbol of control in a seemingly
Three-layer device.
Sorry about that. This one here, this one here. This one here, this one here. I don't like this. Let's go this one, this one here. A little bit left, let's put this one here. Another jam here. Let's put that one here. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed.
Sorry.
But at least he is exact, for the most part.
Those are different networks interconnected through the router.
As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will. As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address, or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again.
My eye, OSU does not have proxy. They are liberal organizations.
Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet. And it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the internet.
Another inaccurate explanation. When you lose an IP packet, IP doesn't do anything. But he has a good friend, always follow him, and that's called Icmp. And Icmp is the actual protocol that let the sender know that your IP packet was dropped for any reason. But still, the sender will not send anything back automatically. Only for the protocol, the service that requires higher reliability, you send an additional resource, the manager or supervisor, that's TCP. So only TCP allows your source to retransmit anything.
A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now the net is an entirely different environment than you'll find within the protected walls of your land. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the worldwide wait. But when everything is working smoothly, you can circumvent the globe 5 times over at the drop of a hat. Literally. And all for the cost of a local call or less. Near the end of our destination, we'll find another firewall. Depending upon your perspective as a data packet, the firewall can be a bastion of security or a dreaded adversary. It all depends on which side you're on and what your intentions are. The firewall is designed to let in only the...
You see the numbers? Can anyone guess what those numbers are?
Ports.
Port numbers, yes. So the basic firewalls use the port numbers to decide whether you should allow it in or just drop it or delete it. And where do you have port numbers? It's somewhere in your message as well. But it's higher up. We haven't covered it yet. Port numbers are used by transport layer protocols.
Those packets that meet its criteria. This firewall is operating on ports 80 and 25. All attempts to enter through other ports are closed for business. Port 25 is used for mail packets, while port 80 is the entrance for packets from the internet to the web server. Inside the firewall, packets are screened more thoroughly. Some packets make it easily through customs, while others look just a bit dubious. But a firewall officer is not easily fooled, such as when this ping of death packet tries to disguise itself as a normal ping packet.
It's okay, Quorum. It's okay. No problem. Have a nice day. We out here. Bye.
For those packets lucky enough to make it this far, the journey is almost over. It's just a line-only interface to be taken up into the web server. Nowadays, a web server can run on many things, from a mainframe to a webcam to the computer on your desk. Why not your refrigerator? With a proper setup, you can find out if you have the makings for chicken cacciatore or if you have to go shopping. Remember, this is the dawn of the net. Almost anything's possible. One by one, the packets are received, opened, and unpacked. The information they contain, that is, your request for information, is sent onto the web server application. The packet itself is recycled, ready to be used again, and filled with your requested information. Addressed and sent out on its way back to you. Back past the firewall, routers, and on through to the internet. Back through your corporate firewall. And onto your interface. Ready to supply your web browser with the information you requested. That is, this film. Pleased with their efforts and trusting in a better world, our trusty data packets run off.
Any questions so far? By the way, I'm not sure where they got that idea, or why they didn't even mention. But there's no reuse, no such thing as a reuse of data packet. It's just ones and zeros in electron, so you cannot really reuse anything. Just recreate everything.
Around 17.
So now we know that firewalls use port numbers to determine that they should allow something in or just block it. And those port numbers represent different services. And different applications use different ports. So that's how you map application with ports and the service. And the address scheme that transport layer protocols use is the port number. So in the data link layer, you have multiple devices within a single network, and you use MAC address to address different devices, computers, printers, and things. They are all addressed with MAC address, right? those are the ones that are actually used in delivery of any frame. And then on the whole internet, you have IP address that represent different devices. So each device has an IP address. Your cell phone has an IP address, your computer has an IP address, your smart TV has an IP address, and everything. But within each device, you have multiple applications. So you have to address the application as well as the IP address of the device to point out where I want to contact. Okay. Who do I want to communicate with? I want to communicate with your server, web server on the IP address. So you have to have IP address plus this port number. So port number is the address that transport layer use to represent different process. Make sense? So port number is also another type of addressing scheme used in different layer, and that layer is transport layer. Then you have application layer. Most of the network service that you use are implemented in the application layer. And as you can see, you have SMTP, that's the protocol for
Email.
Yes, email. Telnet is for, we talked about Telnet last week briefly, right? That's the terminal window that you can remotely access the server, which is not recommended to be used on the internet, but it's okay within a single data center or something. Then HTTP is for web service. So those are the ones that users interact, and they have their own address, right? URL has, so HTTP has URL to point out different resources on the internet, web. And you have email address for your SMTP service. You have Telnet IP address and port number. So, of course, Telnet needs a server. Server has its own port number. So application has their own addressing schemes, but different applications use their own address, so there's no general scheme that you can just remember. And just like the others, you have a message that include the data. Oftentimes they are from the user, like an email content, the message and the title and the data. And the header will include the address and other stuff, like the sender and the receiver email address, the service providers, like what mail server you want to use, what kind of character set you used in the letter, so the receiver can properly interpret the content in the message field. So the whole thing will go down to the lower layer, which is transport layer. And we didn't talk about the details of the transport layer protocols. We'll go back and talk more in details later. But UDP and TCP are widely used. Don't worry about SMTP. I believe it's safe now to say SMTP failed in the market and it will never come back. Although UDP and TCP are not the only two, but they are predominant ones. And depending on what service you are talking about, they may use UDP or TCP or both. So they create their own message as well. So the whole application layer message will be encapsulated inside of transport layer message, which will also have its own header. So every time the user message goes down through this step, user type in data that goes into the data field of the transport application layer, which will add the header, whether that's email address or web URL. The whole application message goes down to the transport layer. This can be either TCP message or UDP message. They also add some header, and port number will be included in their header, right? Because port numbers are the addressing scheme for transport layer. And the whole transport layer message, either UDP message or TCP message, will go down to the network layer, where you have what? What's the name of this message unit in network layer? Packet, yes. IP packet we'll have a data field that will include the whole thing, so encapsulate it, and then add header. So here you have IP addresses, as well as some other header fields. The whole IP packet will go down to the data link layer and encapsulate it in the frame data field. And the frame has a frame header, frame trailer. Okay. And then this will be passed down to the physical layer, where ones and zeros in the frame will be converted to a signal. Okay. So encapsulation happens from layer 5 to layer 4. You cannot really tell the end user typing in a message is encapsulation, but once the application layer creates its own message, the whole message will be encapsulated in the transport layer. So one encapsulation, another encapsulation, another encapsulation. Not here because that's more like transformation. And then here, the receiver receives signal that will be transformed to ones and zeros. So signal to data. So data to signal, signal to data. And that will be passed up to the data link layer. So from there, data link layer process will understand and do some things that it has to do based on the header and the trailer. Well, that's trailer, I guess. Trailer and header. And then take out the content, the payload, inside of the frame data field and pass it up. So taking out the data for the upper layer is called what? Decapsulation. So decapsulation happen here, another decapsulation, another decapsulation, and another decapsulation, and then pass it to the user. Encapsulation happens on the sender side. Decapsulation happens on the receiver side. Who is providing whom? The lower layer provides service to the upper layer process. But logically, this encapsulation, decapsulation process actually shows the flow of the data, the ones and zeros binary data from application layer all the way down to physical and back to application. Logically, the modules, the network modules on each layer, just assume that it's talking to its peer in the same layer. They don't really care what happens in the lower layer. Just pass down their message and just trust that the delivery will be handled by the little guys in the lower layer. So application layer process, for example, web server, just assume that it's talking to web browser, no one else. It doesn't care whether it's gonna use TCP or UDP, what happened there. No, I don't care. What happened in the IP? What if someone lose my packet? Application process don't care about that. They don't even understand how the whole internet works. As long as web server use the same language as web browser, that's fine. And so that's what you call layer-to-layer or peer-to-peer processing. Okay? In transport layer, if the sender use TCP module on the sender computer assumes that the communication partner, whoever read its own message, will be transport layer TCP module on the receiver. Doesn't matter again what happens in the below. IP packet assumes that the header that IP module attach will be read and processed by another IP module, another IP module, another IP module in the same layer. Does it make sense? So when you develop a product for networking and communication, you don't, and if you are developing a product that is just working in a single layer, you don't need to know what's going to happen in the other layers. You just assume that whatever your program spit out will be fed into the same type of program working in the same layer somewhere on the internet. Another thing to remember is, in the intermediaries, the routers and three-layer devices, only the bottom three layers will be involved in the delivery of the packet. Transport layer and application layer are involved only on the sender computer and the final destination computer. Any question about this? So then let's talk about some devices, the actual physical device, although these days many of these became virtualized device. In the bottom layer, physical layer, you have repeaters and hubs. I mentioned about that briefly today. So repeaters, I showed a picture of a network device that looks like this. You have lots of ports here. And they have, each of them have a couple of LED lights that's blinking, fancy, and all the cables are connected to those. Repeaters and hubs look like this. You have bridges and switches. How do they look like? Like this. How about routers and layer 3 switches? Like this. You cannot tell the difference by just looking. Indeed, we had two high-end, not high-end, corporate level layer 3 switches in the lab, and 9 layer 2 switches, all donated by a former student. And he also donated a license. So when I plug that license in and get an update and updated the software, layer 2 device became layer 3 devices. Now we have 11 layer 3 devices. So they look exactly the same, they have ports, but the difference is how many layers of functions are performed in those boxes. Physical layer device has only the bottom layer. It cannot understand data link layer frame. It cannot understand MAC address. It cannot do any filtering. Whatever it receives, whatever you receive in one port, the exact same ones and zeros will be converted to signal and regenerated each and every other ports on the hub or repeaters. So that broadcast, it floods every connection with the same data, same frame, just copy and regenerate. Whereas data link layer device that looks same but has more processing power and memory, smart enough to understand data link layer protocol, can do filtering. So if a frame comes in and the MAC address says, hey, I need to go to a device connected to this port, then the switch will regenerate a frame on that port, but not the others. So all the other devices connected to other ports will be left in a quiet, nice environment. They don't have to deal with all this noise. They can reduce the throughput of the network. So the only difference between physical layer and data link layer connection device, the second one, the data link layer, can understand MAC address and filter unnecessary frames out. So in olden days, so we are talking about like early 90s, we had hubs and repeaters. I couldn't see, so when I was working in the field, it was mid-90s, still we had only 1 or 2 switches in different locations, but mostly we had hubs and repeaters. And what happens when you have lots of ports on a hub and connect all your computers in the same hub? The the throughput, network throughput just plunges down because everyone talk and they collide to each other. So you have lots of collision and retransmission and everything. So hubs and repeaters are dumb device. Just what they hear is what they regenerate to every port. Flood everyone with the junk frames, except for one. And then we had switches. So when you say switches, they are usually layer 2 switches because that's when we first got that name. So people call it switches when they got this smarter device rather than hubs. And there, no matter how many computers you connect, only the receiver computer will hear the frame. All the others will not hear anything. Irrelevant. And then you have these routers. Routers are not only, so every time you go up, the upper layer device also include the functionality of the previous lower layer device. So all switches have repeating function. Whatever they receive, ones and zeros will be regenerated on the forwarding ports. So the receiver will get freshly baked, new, clean signals. Not like analog signals that have lost. And then routers sits between different networks. So rather than filtering anything, they just forward. Routers decide which port is the right network or pass to the right network for individual IP, destination IP address. So as you saw in the video, the router, of course, that just pick it up and just drop it. No, pick up, read the IP address. And then it goes to its routing table. There's a little table that every router keeps, and that will show what IP address is best to forward. And looking up that information, it decides which port of this, because each of these ports will be connected to different ports, different networks. Which of this is best for the particular destination? That is decided by the router and then regenerated, just like switches and hubs on the particular hub and particular port. So those are repeaters, switches, routers, difference between repeaters and hubs. How many ports you have? Repeaters are the original name, and in that time, usually you have 2 ports. Comes from right side, goes out to left, left side in, right side out. If you have more than 2 ports, you call it hubs. And the cheaper switches had only 2 ports, then in that case, you call it bridges. The left side segment is connected to the right side segment. If you have more than 2 ports, then it's switch. Routers, again, the early routers, like the original Cisco models, they have only 2 ports. That means you can interconnect only 2 networks. So right side network, left side network. And if you have more than 2, and then have some additional functions, then they need some fancier word or way to differentiate the original router and the newer routers. So they start to use the term layer 3 switches, or smart switches, or programmable switches. They're, if you have 48 ports on your smart switch, then you can connect 48 different networks on the same router. Looks fancy? All our routers downstairs have that functionality. These days, those are kind of norm. That's average. So we have 50 ports on each of those devices, but 2 of them are actually the same thing. So, no, actually 50 ports, 50 separate ports. So each device, so each of those 11 devices we have downstairs can interconnect 50 different networks per device. And then transport layer device. So transport layer, where you have UDP and TCP, what address they say they are using? Yes. And did we see anything in the video that works based on the ports? Firewalls. So firewall has to read the port number to determine whether it should allow the packet in or not. So firewalls, the typical original firewall, first generation firewalls, have to read not only IP address but port number as well. So it has to understand IP protocol and TCP and UDP protocol to find out where in the whole message shows the port number. So firewalls are layer 4 switches, or layer 4 devices. There are several different types of firewalls, but most firewalls have 4-layer functionality. But better ones, which is called content filtering firewall, or proxy servers, or application gateways, are working in all 5 layers. They have to understand everything, not only regenerating signals, but also understand IP address, port number, and the application level protocol. So for example, proxy servers. So if you have a proxy server, usually handles web communication, all the web traffic, it will be funneled through the whole corporate network to that proxy server. So the proxy server is a gateway in a sense. Let's say if this is a web proxy, HTTP proxy, every computer in the company will send their web traffic to the proxy server. The proxy server will inspect the packet and then forward that to whatever web servers sitting outside of corporate network. So basically, you cannot hide anything because you cannot create a direct connection to the outside web server. To do so, this proxy should understand the HTTP language, because only when you understand the HTTP language, you can interpret the header. So what's written in the header, what's the content. If you don't know where the URL starts and where the URL ends, you cannot inspect the URL. You cannot find any word. Also, if you don't understand where the body starts in HTML, you cannot inspect the user input. Okay? If you search some words like that, okay, inappropriate words, or anything that is not allowed, like a social security number type of format, proxy can read through the message and point it out and block them. So to provide that kind of functionality, this proxy server should include all 5-layer functionality. And content filtering firewall does similar things, but usually content filtering firewall can cover multiple protocols. It can inspect email content, so you can find out the phishing emails. If it's likely to be a phishing email based on the content of the email, then firewall can actually block that or give a warning to the user. Application gateways, those are special type of gateways or proxy servers. If a server can understand 2 or more application layer protocol, it's like having a bilingual friend. You can speak in English and you want to talk to someone who can only speak in French. And you have a friend who is bilingual and speaking both English and French. You can talk to the French-speaking people as long as you have a friend in between, right? Imagine you are writing an email. What email program do you use these days?
Gmail.
Gmail? What program do you use? Browser?
Firefox, yeah.
Firefox, okay. Does Firefox have email client? Does it use port number 25? No. You are using web service, okay? So you create an email on your browser, and the browser talk to web server, right? Browser cannot talk to email server. So you have web server that talks to your browser. And you are writing an email. It's not email, that's just message in HTML format. And that will use HTTP language to communicate the content with the web server. But the real email that you can receive should have SMTP server. That's how the email can be forwarded based on the email addresses. So what you have written here should be somehow converted into SMTP message, which has totally different message format and totally different communication protocol. Who talks first? What's the first words to say hi? How to exchange the content? How to point out who is the receiver and things like that. So you have to have a special server called application gateway who can speak in both HTTP and SMTP, understand HTML, convert that to SMTP message to actually forward your message to the next server, SMTP server. If you use Google or Gmail, Gmail has SMTP server. And that SMTP server must forward your email to the destination. For example, if you're writing an email to your friend who is using OSU email, OSU has its own SMTP server. So this will be Google SMTP server. This is OSU SMTP server. How do you read your email in your OSU mailbox? Browser again. So there will be another step there where SMTP message is converted into HTML through HTTP communication. Okay? So another conversion here. To do so, you have to have a gateway server again. So although you are using it every day without thinking much, we are using application gateway all the time these days. So make it easy, making everything doable on the web, because everyone loves web browser. Who needs Outlook? I still have Outlook installed on my computer, but rarely use them these days. Those are real SMTP clients. They don't use HTTP. It creates a message and uses SMTP directly to shoot out emails. It uses POP3 or Icmp. That's another protocol you use to retrieve your emails. Who cares? All use HTTP because they provide application gateway somewhere. So when people ask, hey, I have this kind of product, where should I put this? Then you have to think about what layers of the functionalities are covered. You don't want to have an overlay of different device that does the same thing again and again. If something goes wrong, you have to find which layer is causing problem. If that's the layer 3, then we have those devices there, so I have to check those devices. So you have to understand what functions are done in what layer and what device you have in which layer, so you can point out where to look, where to start to look at if something goes wrong, or if you're developing something, where to position your product in these layers. Any question? Addressing. So we have covered this many times. So MAC address is for what? What layer? Data link layer. IP, network, port number again, transport. And then in application layer, there's no special name, just application layer addresses. So physical address is MAC address, but physical addresses are not used by physical layer. They are used by data link layer process. Logical layer and logical address are IP addresses, port numbers. If you click this link, you can see the table, a table of port numbers. So you have port 1 through, see, lot. 65,000 or something port numbers. You don't have to memorize this. Good, right? But you will end up memorizing a few of these anyway, because there are some popular service. We will go over there again and again. So 0 is not used, but some are used by some application use TCP only. So here, yes. Some says no for UDP. So this one just use TCP. Some use UDP only. A few use both UDP and TCP. So just look up the numbers that you have heard a lot. 25. Port number 25 is for SMTP email service. Port 80 for web. Port 21 is for FTP. Port 23 is also, I'm sorry, port 20, yeah, port 20 is also for FTP. 22 is for SSH. And 23, the next one is Telnet. So all those very popular protocols have this low number, less than 100.
Say that again.
The lower number, small numbers, are usually assigned to very popular service. The thing is, this is centrally controlled. Okay? There are numbers that you can just use whatever you want in certain range, but this low number range requires a registration. So we'll talk more about this in the transport layer, but port numbers are divided into 3 groups. The first group, first couple of groups, the first and second group, are for servers, services. So when you say a type of service like HTTP, there are a list of port numbers that are assigned to that service. So you cannot just pick any number just to use it. What happens if you use certain port number that was assigned to another service?
And they go through.
In most cases, nothing will happen. It's centrally managed, but there's no law enforcement on the web. So if one company decides to use port 80 for their game software, and they keep using it, nothing will really happen. So, for example, in olden days, I don't know if that's still the case, but internet service providers don't like the large traffic on residential connections. So if you just pay like $30 for one IP address for your home connection, and you're running website where gigabytes of movies are played, ISP are not very happy about that. So they decide to use a firewall. This is an old example. When I was in Buffalo doing my PhD, so that's like early 2001 or 2002. So I had a web server and realized no one could contact my web server at home. And then I just dig around and found that the ISP, what's the name? Adelphia, something like that. So that ISP had a firewall that blocks all the traffic going to port 80 on the residential network side. But port 80 is registered. It's a well-known port for web server. But if you install web server, there's an option that you can choose the port number you want to use on the service side. you use port 80 because everyone knows it's port 80. So if you use that default number, anyone can access your web server without additional information. But if you know the additional information about the port number that you particularly like, you can change it to any number. So I just used one of those numbers that should be used by a client side. So the ISP could not block it because they block those numbers. Some users cannot use legitimate service. So those are, like, again, registered, but there are many examples that some applications use registered number illegally, and there's no easy way to control it. All right. Specific address for your applications. And if you're developing a network application, you should be able to indicate who you want to talk to. So on the whole internet, you have to specify a single process that your application wants to talk. Like if you are playing network game and your application game software needs to contact the co-player and exchange the text communication message, what's the necessary address information? IP address itself cannot specify the target because your game PAL probably have dozens of different applications running on the same computer. So you need the port number. The port number itself cannot specify that process on his computer or her computer because there'll be millions of IP addresses listening to the internet, right? So you need both IP address plus port number when you are talking to a process on a particular computer. And there's a special name for that. IP address plus port number together is called the socket address. So socket is the logical concept where two processes are connected together through a socket. If you're developing a network application, you will probably need to use socket addresses. Again and again and again, each layer is different address. And there's no way that you cannot remember which layer is used by which layer, which address is used by which layer by the end of the semester. So you better memorize this sooner than later. Socket API. Question so far? We are not going home yet. So not asking questions doesn't help you go home all year. If I forget, if you go to the website, course website, and quiz page, you will see a quiz. From your perspective, yeah. One quiz active now. And if you click it, it will say, hey, you need the password. So you have to type in a password. That's the attendance check. Whether you get 100% right or 0% right for the quiz doesn't affect your score, your course grade for this particular quiz. But the fact that you attempted this quiz within the next couple of days will give you attendance score, because that means you know the password. And what's the password? I forgot.
Is there a space in between there? I've used it as a password before.
No, that must be simpler than that. I think it's today's date in special format. 2018080. No. In the next couple of days. I'll probably check it over the weekend. So you don't have to build a good score, because this quiz is basically to help you go through different topics and concepts and terms that you need to understand. So this will be your exam guide. Use this as your exam guide, unless you want to go through the book in the first place and then go back.
Do you get different questions if you take it multiple
Yes,
times?
yes, good question. So every time you try, you will have different set of questions. So you have to try multiple times to exhaust the whole question bank. And the questions that you will see in the exam will be randomly selected from this question bank. So if you remember everything here, then you will be fine in the exam.
So on the question bank, roughly how many questions are in each question bank? Like, are they different each time?
Yeah.
Okay.
Depending on the chapter, some are really big, and you have to go through like
10 times.
10 times or even more to exhaust.
So is there, okay.
The
I just want to know how to know how many questions there are so I can study all the questions.
There's no way that you can say 100% sure that you exhausted all the questions, but you will feel that I don't see anything new and I know everything. So the reason that I make you go through the same question again and again is not to let you just write down a question and answer once and then forget about it. You have to go through the same question again and again. If you remember the answer, it will be fast and easy. Okay? And just going through them multiple times, you remember things. Yes.
Does it give you the right answer if you get it wrong, or just plays incorrect?
After you finish, I think you will get which ones are right and which ones are wrong, but you don't get the right answer. Any other question? Since we don't have much time left, let me just go through this stuff that I brought. So I was planning to show this while I'm covering the physical layer, but since we don't have much time, we already saw this stuff, right? These are Ethernet card, and remember, by the way, the next slide deck has how many slides?
81.
81. It's okay.
Should have a few. Are you gonna cover those all in one class?
Yes, but I'm not going to cover, well, that's the plan, but I'm not going to cover every slide. This is also kind of study guide. I'm not going to cover basic concepts. I'll skip some slides, assuming that you know those concepts already. But once you go back home, go through the slides, and every time you find some terms or concept that you don't understand, you didn't hear from the class, then you have to go back and look up the textbook. And still, it's not confusing. Post a question on the discussion board. So far, at least in the market for end users and companies, we have 4 different generations of Ethernet. We learned that we have physical layer and data link layer. Physical layer is where actual signals are generated and understood, converted to data, back to signal. And then the data link layer is where you put ones and zeros in the right order, in the right format, right? So Ethernet includes both data link layer and physical layer. And we have 4 generations of Ethernet so far, widely used. And the message unit itself has never changed. It's still the Ethernet frame, same frame structure, same length as the ones in, when was that? Okay. 30 years ago, 40 years ago. For backward compatibility, we never changed anything in the data link layer part. But it changed the physical layer part, so the same message, same frame can be transformed to signals in much faster speed and using different medium. From this cable, the first generation Ethernet had several physical layer standards that you can work with. So in this table shows you see different physical layer standards that all worked with the first generation Ethernet. Okay? So the data link layer is the same, but in the physical layer, you could use this thick coaxial cable, or you could use thin coaxial cable, which is this one. This one has 500 meter limit. This one has less than 200 meter limit. And then 10 base T is the typical unshielded twisted pair, or UTP cable. I have a few UTP cables, just like what you have on your computer. They look the same, but those ones used here is much lower quality. It has less twist, and the medium quality is low. So if you use them in today's environment, you will lose the speed, or even get too much error, and your network will not work in an acceptable level. So I will pass this around. So these are Ethernet cables. Take one there, one here. Yellow one is the thick coaxial cable. Black one is thin. Careful, it's pointing. Depending on what medium you use, the physical standard on this card has to be changed. So for example, this one has 2 interfaces. One for 10 base T, so UTP cable can go through here, through RJ45 jack, the clear plastic jack, just like a little wider than the telephone jack. And then thin coaxial cable go through here. Let me just connect this. So if you look at this medium, you need a special part called T connector. They look like T-shape. And that gets the medium on both sides, and then the center part goes through this connector. And at the end of, so this is bus topology. So multiple network cards will be connected like this, again and again and again. And at the end, you have to put this little piece of metal called terminator to properly seal the signal so they don't just dissipate and create a noise. Which will, as soon as you take this out, none of the computer will communicate properly because they get too much noise through this. And for the thick yellow cable, we have this external physical connector component because it's too big to include inside of the computer or on the card. So you have card just connected to this connector module through thinner cables. This is thin coaxial cable. I just showed it. It's look very similar to the CCTV cable these days. And then the typical network cable that I just read. It's called UTP, Unshielded Twisted Pair. Of course, it has a shielding outside, but shielded has much more shield inside, and very thick and hard to bend. So these ones are unshielded. And if you look at the inside, you have 4 pairs of color-coded conductor medium. And each pair works as a single medium. So you have 2 lines, and the actual voltage difference between 2 lines are measured as ones or zeros, rather than using individual piece as a transmission medium. So you have 4 channels of conductor medium here. Can you pass this around? And I got this from somewhere. This one has also 4 pairs of conductor medium. Looks like STP, shielded twisted pair, but I'm pretty sure this is not standard TCP, STP. STP can be thicker than this, and shielded is not very up to the standard. This may be special unshielded twisted pair for special environment, like fire hazard or physical stress or something like that. Next, please, Rahul. So you have to pick the right medium because they cost a lot. So you have one single data link layer module that can interact with multiple physical layer devices or standards, and some physical layer standards used only 2 pairs, whereas some others use 4 pairs. If we talk about fiber optic cables, which are pretty popular these days, we have had fiber optic from the very beginning of Ethernet, although the speed was pretty low, lower than copper these days. The thing is, when you have fiber, you cannot transmit data through a fiber to both directions. So you have to have 1 thread per direction. Usually you have 2 threads of fiber going together. These are examples of fiber optic cables. And they follow different standards. I think orange one, you have to look at the numbers on the cable. If you look at the cable, if you have good eyes and try to read it, there are 2 numbers with a slash, and that shows the specification of these cables, and we will learn about them in the later chapter. The one is for long distance, higher quality, you lose less signal. The other one is cheaper for shorter distance, good enough for within a building cabling. And which cable you need to buy depends on what device you have. So depending on what transmitter and what standard your intermediary switches support, you have to pick different cable. Even if you have extra money and buy the best fiber optic cable, that may not work for your device if the device does not support high quality fiber. The second generation is called fast Ethernet. So first generation, just Ethernet. The second generation, fast Ethernet, which is not fast at all in today's standard. That ran at 100 megabit per second speed, 100 meg. today we have 1 gig or 10 gigabit per second speed. That's third and fourth generation. So again, for same data link layer, we have different physical layer standards that requires different types of medium, different types of connectors, different speed, and different transmission maximum distance. And also the actual coding, what kind of signals are created, and how you map the ones and zeros to different types of signal, also determined by different physical layer standard. So for gigabit, you have 1000 base SX. We'll talk more about what each component in the code means. 1000 or 1 gig, basically it's the speed. We have fiber, short wave, long wave, depending on what kind of light signal you use. Some light signals have a longer wave than the others. We have long wave signals that tend to keep their signal strength much better in long distance. And depending on what type of light signal you use, you have to use the right transmission medium for the right application. Okay? Some support 550 meter, which is still good. Some support only very short distance that use STP, shielded twisted pair. So if you use copper, you cannot extend the distance a lot unless you add the repeater. And for 10 gig, you still have some copper standard in physical layer, but mostly you have fiber to take advantage of the speed. And for different standard, you have to follow a different medium standard as well. So if you look at these numbers, laser wavelengths, that's the specific type of light signal that you need to use to support that distance and speed. And depending on what light wavelengths you need to use, you have to choose the right fiber optic cable that can allow that type of light signal can go through the fiber. So that's why I carry one of those fiber optic cables around, because they are expensive, but I found a bunch of them in a cabinet, and it seems like someone bought a bunch in bulk and found that they were not the right one. So they just abandoned it. Then we have some other types of network cards. I think these are from old servers that were donated, and by the time we got the donation, I realized that they are too old to use. So I just take some pieces out and just abandon again. It seems like these are FIDI. This is another type of network card that use fiber only. And as you can see, there are two holes, one for transmission, the other one for reception. And they were used in data center a lot to connect storage layers, high-speed storage layers to servers in olden days. These days, Ethernet can support them as well. And for the high-level internet service providers that support the regional, state level, or international level, they use one of these. Those are high-capacity, well, these are old ones. The copper coaxial cable, they are pretty expensive and hard to work with. These days, this can be just used as some kind of weapon or something. But these are fibers. Once you dig the ground, you don't want to put only one thread. You want to bury a bunch. So you have a bunch of these cables that has dozens of fiber threads in it. And there is a conductor medium, but they are not real conductor medium. They are metal to strengthen the physical characteristics of the cable, or just have a low level signals to let the workers find out where the cables are buried. It's not for data communication, but once you bury them, you have to find out where they are buried when something is wrong after 10 years. So they usually have a cable that can be detected by a sensor. Any questions? All right, so if we are done with those things, please bring that to front, and we'll see you next week. The quiz, you have to try at least once before the weekend to prove that you are here. But after that, I may just remove the password. You cannot claim the attendance point from that point, but you have unlimited number of chances that you can try again.